So hello everyone, this is Akshay here, and let us continue with today's problem today. And few last things before starting the problem is this is our YouTube channel, and there's a DSL repository. You must start and to get help with your interview preparation. And I have solved around 500 days of code here, and that's what got me into the product based like companies like Mastercard. And let's quickly come down to this today's problem, the Knight's Tour problem. It is same as the number of questions which we have been solving in the past. As you can see, right in a maze, expression add operators, possible words from phone digits, unique key numbers. All these questions were the part of recursion and backtracking. So what it says is that at one point you need to explore multiple instances, like a knight can move at 8 positions, right? 8 possible positions. Similarly, for rest of the questions, we have rat in a maze and it can explore another all the positions which has been marked as one and not as zero, which counts for the obstacle, right? तो सेम क्वेश्चन है, हमें कुछ भी यहाँ पे ऐसा अलग नहीं करेंगे. The same which we have been doing since the last 4 days. So the total concentration for today's video will be on writing the code, and the only explanation part which we need to cover is that in how many directions the knight can move. That is to say, how we can form the dx and dy array, and rest of the explanation, intuition, and the code would be same as we have done in yesterday's video. See, that's the thing which I was talking about. In the yesterday's question, we just formed this dx and dy array, and we had this direction character which corresponds as the first entry goes to up, and then right, down, and left, right, so on and so forth. And then we just backtrack, or we recurve for all the 4 directions, and then we backtrack at this point. So just understand this question, what this question has asked, and how have we approached this question in the yesterday's video. And after that, you will be fully equipped on solving today's problem, right? So I'm not gonna waste time on explaining the concepts and intuition again. Instead, we just gonna form the dx and dy array, and we'll start the live coding. But before that, let me just give you one quick glimpse of what the question exactly says, and then we can go ahead with the. So here comes our question in which we have a knight. Knight चेस का knight यार घोड़ा भी कहते हैं उसे, and हिंदी में कहें तो वो 2.5 कदम आगे बढ़ता है. अगर ये इधर है तो 1 and second, and then this one. Similarly, it goes like this, it goes like this, and all in the 8 directions. We will see how many directions are there, how can we form it, and what are the values associated to it. So you need to return the order in which the cell is visited. If the solution exists, we need to print the sequence of numbers representing the order of visited squares, right? तो इसका सिंपल सा ये मतलब है कि देखो यहाँ पे चेस बोर्ड है 5x5 का, राइट? तो इन्होंने कहा है कि सबसे पहले हमारा चेस बोर्ड का नाइट was स्टैंडिंग एट 0,0, and the ask is that it should cover all, or let's say each and every position in 5x5 cell, right? As you can see, let's say the knight was starting at 0,0, so the first move it makes here, right? And then from 2 it goes here, from 1 it goes to 2, and then from 2 it again goes to this position, right? So at any point you will see that जो हिंदी में कहते हैं हम 2.5 कदम, that is always maintained. And then from 3 it goes here, 3 to 4, and then from 4 it goes to, where's 5 written? 5 is here, right? So basically ये क्या कर रहा है कि at each and every position it is exploring all the 8 directions, right? And once, if it is not able to reach, it's recur back, it's backtrack, and then uh, it just says that we, if our total number of moves is not is equals to n cross n, right? Then that definitely means that we were not able to, or that knight was not able to cover all the possible cells in this given n cross n matrix, and we, in that case, we'll just say return, right? So let us quickly form that dx dy array which I was saying about, and we will start writing the code. So today's video is all about writing the code and intuition and problem statement, and how are we writing recursion and backtrack. These are for yesterday's video. That's important for you before going ahead with this one, right? So let me draw a matrix for you so that I can show you all the 8. So yeah, let's now start mapping the all the 8 directions and the corresponding coordinates with it. So let's say the knight was here at x comma y. The first move, or let's say one of the possible moves he can take, is it can go here, and simultaneously we'll be writing the coordinates. So what would be the change in coordinates at this point? So this was x row, so this will be definitely x minus 2 row, right? And this would be x minus 3. This would be x minus 1 row, x row, x plus 1 row, x plus 2 row, and x plus 3 row, right? Similarly, if this is y, then this would be y plus 1, this would be y plus 2, this would be y minus 1, this would be y minus 2 column index, right? So using those, we will just track the indexes of rows and columns. So this would be nothing but x plus 2 and y plus 1, right? So the next move it can make is here. It goes straight up and then take a left. So what would be the coordinate of this one? It would be x. What is the value of x? X minus 2 and y minus 1. Similarly, what other directions it could take? It could take is that go down and then right, go down and then left. And from here, it can go like 1, 2, and then above, and then 1, 2, and then down. Similarly, in the left direction, 1, 2, and then above. So these are the possible. I'm just marking it with a dot, and these are the ones, right? So let's just quickly name the coordinates now. So this would be x minus 1 comma y plus 2. Am I right? Yep. And this would be nothing but x plus 1 comma y plus 2. Similarly, this would be nothing but x plus 2 comma y plus 1, and this would be x plus 2 comma y minus 1. Similarly, for this coordinate, it would be nothing but x. What is this one? This is x plus 1 comma y minus 2, and this would be nothing but x minus 1 comma y minus 2, right? So what would be our final dx and dy array? So let us form the dx and dy array. So let's start from here. Let's start from here and go like this, right? So dx would be nothing but minus 2. Let me write in this. So minus 2 and the corresponding y value would be 1. And then similarly minus 1, 2, then 1 and 2. And then we have 2 and 1. Then we'll be having 2 minus 1, and then 1 minus 2, and minus 1 minus 2, and then minus 2 minus 1, right? So this minus 2 minus 1 comes from here, right? And then so on and so forth for all the respective values, right? So we'll just make this dx and dy array in our corresponding code, and we'll start the coding section. Please pause this video here, try to code this approach by yourself, and then we can resume ahead with the coding. So going straight ahead with the code now. Okay, so take a deep breath and open your code editor, zoom in a little bit, and we'll start with this one. Great. So let's make some dx and dy array. So this would be dx, and we have the values here, and this would be dy. So without wasting further time, let me just fill up the values and you do the same and then resume again. So I've been writing comment as well for the corresponding line of code which I've been writing. So for you to understand in a better way. So Boolean solved is equals to false. It is nothing but a flag to indicate the solution is found. And this will help us in writing our base case of the recursion, right? So again, we have declared here our global answer variable in which the particular moves would be stored for n cross n matrix, and we will be initializing it here. So this would be int of n and n, and we'll be initializing the answer matrix with -1, indicating that it has been not visited. So instead of having a 2D visited array, we will be using the same answer array, marking it as -1. -1 will signify that this cell has not been visited, and once we will visit it, we will fill the number of move for that particular cell we have, right? So we will see that in the backtrack, but yeah, for now, let's initialize it and fill it with -1. So please do the same. Now here goes a function of backtrack. So you name it as backtrack or DFS or recursion, all remain same. So backtrack. So we start with the index, the starting index that is 0, comma 0, and the moves which we have made is 0. And the total uh, matrix size is n cross n, so we'll be passing that integer value of n, right? Now the question says that we need to return in the 2D array list integer, right? So we're gonna do that pre-processing here, and let's just do it here itself, and then we proceed on with the writing our code. So result is equals to new array list. And if we have found an answer, then definitely a solved variable would be updated. And if not, it would be corresponding to a false. In that case, the question has said that you need to return a 2D array list with all the values at -1. So we will be declaring the array list since we have declared 2D array list. So we'll be declaring n times array list, and we'll be adding -1 to those solutions. So let me do. Hmm. So we just made an array list saying no solution dot add -1, and which is a result dot add no solution return result. So I was in the impression key maybe we need to make the array list of n cross n and marking the whole like total number of values at -1, but ऐसा नहीं है. We just have to make 2D array list and just pass 1 -1 and it would be good to go, right? Now, at last, if the answer is there, then definitely we need to convert that answer 2D array. जहाँ हमारा answer store रखा है, that is this 2D array, right? We need to convert this to 2D array list before returning the result. So it's a simple code, so write it yourself and then you can resume. Okay, so here we are converting the answer 2D array into array list format for returning the result. And at last, we just say that we have our, after calling the recursion function, we will be having our answer in this result variable, right? Now let's complete our backtrack function. So let me see public. Okay, so we can avoid the static keyword here, and we will say just backtrack, and we have the static index, let's say int x and int y, and we have int step, and basically the number of counter moves which we are making at every point. And if it is solved, so base case it would be, that's the reason I stored, or maybe I initialized this variable. So if it is already solved, we need to stop our recursion and we'll just say return, right? If that is not the case, then we will first fill our answer variable with the number of move we have, or let's say the current move which we have made for that particular night. So it would be step, right? And the another base case is that if our step, let's say the number of moves which we have made is actually equals to the number of cells, that is n cross n minus n, then definitely. And one more case, that if solved is true. So in that case, we can say that we have actually found our answer and we'll just stop our recursion. So if step is equals to 9 cross n minus 1, that is we have actually made, let's say there was 25, n cross n 25, right? So we made 25 moves and solved is also true, let's say. तो जब अगर हम देखो, हम n क्रॉस n माइनस वन का मूव तभी ले पाएंगे, हमारा स्टेप वहां तक तभी पहुंचेगा जब एक्चुअली वो स्टेप पॉसिबल हो। अगर ऐसा नहीं हुआ, राइट, हमारा स्टेप n क्रॉस n माइनस वन तक पहुंचेगा ही नहीं। रीजन बीइंग कि कभी अगर पॉसिबिलिटी नहीं हुआ तो मे बी आउट ऑफ बाउंड चला जाए, तो हमारा स्टेप कभी n क्रॉस n माइनस वन जाएगा ही नहीं, राइट। अगर स्टेप जा रहा है वहां तक तो डेफिनेटली हम अपने मैट्रिक्स को फिल कर पाए थे, एंड वी कैन सॉल्व, and we can say that we have found an answer and we will mark this variable as true. I hope you were able to understand this point, right? ठीक है, तो एक बार फिर से बता देता हूँ यार, अगर देखो n क्रॉस n 25, अगर हम 25 मूव्स तक पहुंच गए, राइट, तो डेफिनेटली हमने सारे जो मैट्रिक्स है उनको मार्क कर रखा है। तो भैया ऐसा क्यों है कि हम पहुंच गए तो मार्क ही हो रखा है? सॉल्व सॉल्व ही तो हो सकता है, हम 25 मूव तक गए और फिर भी हमारा आंसर नहीं मिला। नहीं, ऐसा नहीं है यार। देखो, अगर लेट्स से तुमने 11th मूव तक गए और 12th मूव करने के बाद यू फाउंड, कोई मूव किया तुमने और उस मैट्रिक्स से ही बाहर आ गए, तो जो बैक ट्रैक अभी हम लिखने वाले फॉर लूप के अंदर देयर विल बी 8 मूव्स, तो वहां पे हम ये भी तो चेक करेंगे ना, सेफ चेक, आउट ऑफ बाउंड नहीं होना चाहिए। सो इन दैट केस ये मूव वहां तक जाएगा ही नहीं अगर पॉसिबल नहीं है तो। आई ट्राइड माय बेस्ट टू एक्सप्लेन इट टू यू गाइस, इफ नॉट जस्ट हियर इट once or twice, you'll be able to get through it. So we have 8 directions and I plus plus, and we'll be forming the new x coordinate, that is new x is equals to nothing but x plus, and what is the variable dx? Dx of I. Similarly, int new y is nothing but y current y plus dy of I, right? And we're gonna have to do a safe check, so we can say just is valid, and we can make one helper function saying is valid. And the variables which we'll be passing is the new x, the new y, and the किससे safe check करेंगे, that is the length of our matrix, right? So it is n cross n, so we'll be passing n. If it is safe, then we will call the recursion function for this new x, comma new y, comma, since we have made one more step towards it, so step plus one, comma n, right? And in this case, if it is solved, then we just say return that we have found an answer, current answer, and then stop the recursion, right? If that is not the case, matlab again the same intuition for regarding the yesterday's question, हम जिस गली गए, हमें वहां से आंसर नहीं मिल रहा है, we are getting out of bound or something else, तो हम वहां से कह देंगे we will just recur back. We'll recur back to a parent call कि we do not have to explore this path, right? So since you have recurred back and you do not want to explore the part which you already explored, तो उसे हम -1 से मार्क कर देंगे कि नहीं, हम इस रास्ते गए थे बट हमें आंसर नहीं मिला, तो हम रिकरिंग बैक और उस आंसर उस पाथ को वापस से -1 मार्क कर दो, सच दैट अगर हम कोई दूसरे पाथ से जाना चाहें तो हमें पता चल सके। एंड we have a boolean valid function, so let me write that and we can resume again. Meanwhile, you can try to implement yourself. Okay, so here goes our summation, and that is again the is valid function. It's very simple. हमने x और y को बस we have just checked if it is inbound. That is, the row with index should be greater than 0 and less than n, and the column index should be greater than 0 and less than n. And that particular answer of x and y is equals to -1. That is, if it is not visited, then only we'll make a move on that particular cell or in that particular direction, right? So that is it. So what would be the time and space for this one? So we are making, so in the yesterday's question, what we were having four moves for each and every cell. So the time complexity was uh, 4 power n cross n, right? And I sh already showed you that how using a GP formula, how did we derive this one? So in the today's question, we have eight possible outcomes, eight possible directions to take for each and every cell. So expected, or maybe the time complexity would be 8 power n cross n. What would be the space? Space would be nothing, but we are using a 2D array list for this answer variable, right? So n squared there. And what else? We're using it array list as well. So it's got return type it, so we can ignore that space. So basically, n square as space and 8 power n cross n would be your time. So till then, keep learning, keep moving by, and take care. Tomorrow is my office. Let's meet you again in the next video. Till then, bye bye.